Warm welcome to all of you. In today's session in data science, we are going to see about exploring the data using series and data frame. Okay, so first we have two topics. One is called as a series and another is called as a data frame. Okay, Pandas offers these two primary data structures. When I say it as a series, it is a single dimensional array. Okay, a single dimensional array of one column is called as a series, whereas pandas might be of two columns or a multi-dimensional columns with rows and columns. So now let us start with the series. What are these series used for? These series are commonly used for data manipulation and analysis. So what are these characteristics of series or data frame? So both the things, if you could see, mainly you can index the elements, you can do the column wise operation, that is nothing but your vectorized operations, and you can do the missing values, how you can handle the missing values, how you can check the missing values, how you can fill the missing values. And suppose if I want to add two arrays, okay, I want to summarize the data and apply the aggregation function, that could be done using both series and data frames. Okay, so in series, if you could see, you have, that is the command which is shown here. It shows the series from list, series from dictionary, series from custom index. That is, the first thing is the indexing could be done either through the list or a dictionary or a custom based index. So when you're going to consider it as a series, so they've just given the command as pd dot series. So it just lists the data 1, 2, 3, 4, 5 and assigns the label or the index as, it will always start from 0. So 0, 1, 2, 3 and 4. Now we'll move on to either I can list the data from a list or from a dictionary. In dictionary, the labels are given because in dictionary you require a keyword from which the data could be accessed. A refers to 1, B refers to 2 and C refers to 3. Default, it takes the data type as integer 64 bytes. The next thing, whenever I'm going to take, I can also choose a custom index. Here the input data is 1, 2, 3, 4, 5 and the index I'm choosing it as a label A, B, C, D, E. So I can make a column either from a list or by using a dictionary, or I can go in for a general specific purpose custom index as per my own application. Series indexing. When I say it as a series indexing, so the datas are given. I am using the command pd dot series dot data, and the data is also given from how to take the data from the dictionary. Now they are asking first the print the data from the list of 0. Okay, so 0 corresponds to the first element, so it just prints the value as 1. Series from dictionary B. B refers to the indexing of the value 2. Okay, so either I can index it from the list or I can index it from the dictionary. Next, we'll move on to the series vectorized operation. When I say it as a series vectorized operation, so I can add the two datas. I can do some arithmetic operations, either it could be addition, subtraction, multiplication or division, etc. So two datas are given. First we have to check both the things are of the same array size. Then we are just giving the function a plus b. So it just adds the values. So I've taken the data in such a way whenever the addition is there, it results in 6. Similarly, I can perform the subtraction process also. So 1 minus 5 is minus 4. Or I can do a multiplication process. So last digit 5 into 1 is 5. So any of the operations could be vectorized by using your series pd dot series command. Now we'll move on to the series alignment. Okay, now if you could see, series A has been given a values of 1, 2, 3 and the index is given as ABC, whereas the series B takes the argument as 4, 5, 6 with the index BCD. Now whenever it is going to write the index or rank the index, so 4 indexes are there, it just writes A, B, C, D. A is available in the first series but not available in the second series. So it takes the value as none. Similarly, D is available in the second one but not in the first one. It assigns the value as none. Now B and C are matching. So this B and C values alone will be added up. So what is B? 4 plus 2 is 6 and C is 5 plus 3 is 8. So which has been printed here. So using series we can also do the alignment process also. Now in series now we'll see how to handle the none values. So we are just giving the values as import numpy as np s is equal to pd dot series. I've just taken a command 1 comma 2 comma the third value I've given as none and fifth value I've given as none. As per the index it is third and fifth. I'm sorry. So what is the value I've given? So the 0, 1, 2. 2 and the fourth value I've given as none. So whenever I'm just giving the command, so it just prints the value and gives the output. Okay. So just with the none command also we can write the code. Now how to check the none values? So I've given the same command I've written. Okay. Now to check the none values, the command used is isna. Okay, so when I've taken a variable assigned as yes. When I give print s dot isna, so it just wherever the none symbol are there, that is 2 and 4, there only the none symbol is there, that is the none values are there. So it returns the value as true. Other values it returns the false boolean value. So thus to check the none value, we have to use the command isna. The next, just to further advance it, you can also use other command called as isnull. Isnull also returns in the same fashion. So both are having the identical output. So now how to filter the missing values? When I give the command s of s dot is null, then it returns that 2 and 4th value is having the missing values. For my application, suppose I want to find which are the data having missing values, wherein I have to put in some values and carry out my next process. Now, how to fill the missing values in series? So, I've taken a general value and if I give the command called s dot fill na, s is just, of course, it is a variable name. If I give a command fill na, then it just fills the values of the places which is having none with zeros. Now let us see. Now in certain places, suppose let us take the people are working in 4 regions, the marketing people itself, north, south, east, west. Suddenly if two people, one from north and one from south leaves the job, but some person should be deputed immediately. So in that case, we require a forward fill and a backward fill provided their working place is nearer or they want to shift it to north or south depending upon their workload or their native place or something example we could take. And here if you could see, so the first one is same place I've given 1 and the third place as none. Okay, first one is forward fill means so it just fills the next value, whereas backward fill means it just fills the above value. So here if you could see in this place initially you have 1, in the next place it just NaN is there, so it fills the same value. Similarly 3 is there, this is a none place, so it fills it with the same value. Whereas in the second case, so here you have the 3, so that value gets updated in the first position. Similarly here you are having 5, that is updated priorly here as 5. So what are the two commands to fill the none? It could be either the forward fill or the backward fill, F fill or B F fill. Now we will move on to check how we could handle the data frames. So as I already told you, data frames are nothing but the data which is stored in rows and columns. You'll be have an index, you'll be having the columns that will contain the data also. So just similar to your series also, here also we will have for data frames also you'll have the indexing or the vectorized operations or how to handle the data missing data, or it could be like how we can group the data and aggregate based on our application. Now we have just taken a small example, import pandas as PD, and I have given three datas, name, age and city of three people, namely John, Alice and Bob. I am just printing data frame, it just prints the value in a tabular form. Now, either I can give the data like this, specifying the headings here itself, or I can just give the data and in the data frame command, PD is equal to df is equal to pd dot data frame, data comma columns equal to columns, means it will take this columns and then it will frame a data frame. Now the next topic is data frame indexing. So in this indexing, what is the command we have taken? The same command as previously, the data, that is name, John, Eliza and Bob, age is given, city is given. You are printing the df, so it just gives with the indexes John, Eliza and Bob with his age and your city. Now I am going to access it by the location, by its label. Location 0 means in location 0, John is living in New York City with the age of 25. So that data peeps in. Next thing, df.ilocation.0, that means it is a position based indexing. It is an integer based indexing. So it just provides the data which is present here. So 25 and New York. The next thing is you can also access an individual element by using the command called at. Okay, so whenever you are going to see the command called at, it gives that you want to choose a variable of name which is at 0th location. So it just gives the value as John. So only the students you should remember, df.log means it is a label based indexing, df.ilog means it is a position based indexing. Next, we'll move on to the data frame column operation. So we have taken the same example. You print DF, you just print the name of 3%, age and city. The next thing, I want to add a new column. I want to add the data to the existing one. That is, I'm adding a salary column. So how to fit in? So just you give date df of salary, the data salary is also getting added. So now a new table is formed along with your salary component. Now the next condition is if I want to take a particular value, that is a salary greater than 60,000, then in that case when I give a command in df, it just prints the value which is greater than 60,000, that is nothing but Bob who works in Chicago has a value greater than he earns 70,000. So that data is getting displayed here. The next thing is that you want to sort, okay, by age, and I'm giving the command as ascending is equal to false. That means it will print the ages by descending order. Okay, so if you are going to find out the if you are not going to give ascending is equal to false, it will take it and print it in the ascending order. When you give ascending is equal to false, it just prints the data in the reverse order, that is in the descending order of age. Thus, by using the column operation, if I want to add a column or I want to find out a specific value in the column, that could be done with. So the last topic, that is the data frames missing data handling. Just similar to the data handling, missing data handling in series, here also we have the same concept. So we have given the data, the structure is with in salary, one of the person detail is given as none. Okay, so if you could see in age one data is none, city one data is none, and salary one data is none. So how to find out, how to check the missing value? If I give the command df.isna, it finds out the where and all none is there, it returns the boolean function as true. Okay, so it just finds out. So this is the way to find out an missing value in the data. Now to count, okay, the missing values. That means same command df.isna, in which you have to put one more additional thing, that is your sum. So it gives that in age there is one missing data, in city there is one missing data, and in salary one missing data. So this could be useful for the data analyst to check whether all the data are available or is my data is insufficient. So with this, how to explore the data using data frames and series have been studied with. So in the next class, we'll be seeing about the how to index, sort and re-index the values. Thank you.